We have a trigonometry chapter. We will explore it in details. First question is in front of you, and you are familiar with this question. You are familiar with this question. Now I want to ask you how to solve this type of a question. This is the first question of this lecture. We are starting with this first lecture. Here we will read this question. What is it saying? Then we will understand. Okay, it is saying to apply some formulas. Then we will apply. If it is saying that you have given this, then you have to apply formula according to question. What is the question saying? Clear? Unnecessary we will not apply. Then it will not make sense. Okay. Now here we have given what sine A is equal to 8 upon 17. It is a given. Whatever is given you can write first of all. Okay, you can write whatever is given. For example, sine A is 8 upon 17. It is a given. Now here from this given, what are we understanding? From this given, what are we understanding? We are understanding that this is a ratio, trigonometric ratio, sine A. Sine A is what? P upon H. Now, yes, sine theta is what? P upon H. It is telling you something. What? It is telling you P is 8, isn't it? P is 8 and H is 17. This is what this given is telling you. Now here we have a value of P, value of H. But we should have a value of 3. Value of 3 variable. First value of P, second value of H, and value of what? B. We should have a value of 3 sides of a triangle, of a right angle. So we got a value of value of 2 sides first. So how to identify, how to find value of not given measure of a side? So here we have to find B. We don't know. So is it compulsory to know what is the value of B? So let's question till here we have understood. Now next sentence it is telling you find the trigonometric ratios of angle A. Okay, of angle A. We now value of one trigonometric ratio which is sine A is how much? 8 upon 17. But apart from this, whatever we have left, apart from this we have left how much? 5 trigonometric ratio, and question is saying find the value of all those left trigonometric ratio. So yes, it will be compulsory because in some trigonometric ratio we will say what? B upon H, P upon B, H upon B. So of course value of we should have value of B. We should have a value of B. So to calculate to find the value of B, here we apply what normal formula which is Pythagoras theorem. P square not B, H square P square plus B square. Clear? Now we know H is 17, isn't it? Yes. P is how much? P is 8. B we don't know. 17, 4, 11, 7, 9, 8, 2. 2, 8, 9 and 64 is equal to B. 2, 8, 9, 64. 5, 2, 2. So b is equal to, it came how much, 225. Here it is a square. Now here we have a square, as you know what will happen. So b came as a 25. B came as a 25. You can write here 25. Now we can easily find value of cos a, value of tan a, value of cot a, value of sec a, value of cosec a. You can easily find, because we have now what, value of all, measure of all three sides of a right triangle. Now it is equal to what, b upon h, isn't it? Value of this is p upon h, this p upon b, b upon p, and h, I think h upon b, isn't it? And h upon p, just opposite of it, this. So yeah, now we will have to substitute the value of this. Here b is how much, 25, h is 17, in this p is 8 and 25. Here b is 25 and p is 8. Here h is 17 and b is 25. Okay, no problem. Now in this h is 17 and p is 8. That's all. This is the final answer. This is what the question was saying. Find the value of all trigonometric ratios. So here there are only 6 ratios of a trigonometry. 1, 2, 3, 4, 5, 6. Those are here. Have a look, then I will finish it to write the next question. Next question I am going to write. This is our next question. How to solve this type of question? It is a little different from the previous question. Here again you have given, and in the previous question something was given, but in this question little slightly will be different. Let's see. It is given, okay, we now, this is 7 upon 8. Now ratio of this would be what? I think b upon p. It is correct. Confidently I can say it is correct. Now it is telling you b is 7 and p is 8. Now what else? B h we don't know. So clearly you can write 14 and 49, isn't it? So 1, 11. hold on. This is a 3, and now it is correct. So h will come as a as a root of 130. 130. Clear? How did 130 come? So here you can see we applied what Pythagoras theorem to bring value of h. Now next read this. It is telling you have to substitute a value of sin theta, then simplify it, and whatever you will get logically, that will be your answer. So we have what 1 plus sin theta. Here we will apply something else apart from formula of trigonometry. So here sin theta, okay, upon 1 plus cos theta, okay, no problem till here. Now here what will we apply? Something else is what? Algebraic identities. Algebraic identity. Here you can see a plus b, a minus b. It is the algebraic identities. Okay, why do we use algebraic identities? So that we use it so that we can save our time. We without rather than going a long process, we can solve it in short process logically. Okay, logically. So here it is what a square minus b square. So this and this will have a minus b, a square minus b square. Clear? So it will be equal to this much. Same here you can see 1 square and cos a square theta. Clear? Now what else? So here you can see what is happening. One as it, and here it is what? Sin a square theta. Can you say, okay, no problem. Can you say sin a square theta plus cos a square theta is equal to 1? It is also identity, but it is a trigonometric identity. We can apply this. If you are not familiar with this, then other method we can apply here. But if you use this, then answer will be same. Answer will be same. Here we can use this. How? Because here we have what? 1 minus sin a square theta. So can we write sin a square theta minus 1 is equal to minus cos a square theta. So of course it can be written as like this. When if we want to remove this sign, then okay. So it is telling you this is value is equal to this much. Clear? Cos a square theta upon, and same here sin a square. So it is telling you how much? I think cot a square. So here what is that? We will substitute. Okay, we will substitute value of this here. So 1. Okay. So here I am not using this. Question is saying after putting this, what will be your answer? What will be your answer? Okay. We can use this, but question is not saying that you will have to use this. No, question is not saying this. So sin a square. So sin is how much? I think p upon h. So p is 8. H is this much. Clear? Upon again 1 upon. So here cos b upon h. 7 a square and h is this much. Clear? Okay. Now let's see here. Over here 1 upon 1. Clear? Minus 64 and this this will cut, this will cut. So 113 upon 1 upon 1 minus 7 sevens are 49, and this will become 113. We have fraction here. It is very easy to you. So it will be 113 64. Clear? Okay. Again 113. So 113 minus, I think it is 49. So this is the same. It will cut. Now whatever we have left, we will write. So here 9, 4, 4, and 9. Okay, 8, 7. I think not 7, 6. So 7 sevens are and 8 eights are. So 7 upon 8. 7 upon 8. This is the value of cot theta. So our answer came 7 upon 8. After solving this, after substituting value of this. Okay. So just have a look. Now next question. We have this complete question. Again, I would say it is a completely, it would be completely changed from the previous. Let's see, but something will be similar. Something will be similar, and here you have a given figure by this question, and figure looks like this. Figure looks like this. Now let's solve it. It is not too much difficult. You can solve it. Here it seems difficult, but look at it. In triangle OPQ, we have what a triangle OPQ, and at P is right angle. Right angle at P. OP value of measure of OP. Measure of this side is 7 centimeter, and OQ minus PQ. OQ minus PQ will be 1 centimeter. Will be 1 centimeter. Can we write whatever is given? Okay, here OP is 7 centimeter. Clear? Now here from this we are getting what? 1 minus 1 plus PQ, isn't it? From this. Now we know what OQ. OQ is what? Hypotenuse. OQ is hypotenuse. So OQ square OP square plus PO. Okay, OQ and PQ. Okay, PQ square. Okay. Now it is given. Yeah, it is true that we don't know exact value of PQ, but we can find. Okay, we can find how. You can say I am finding. So 1 plus PQ, it is what? A plus B square. We will apply with algebraic identities because it is telling you that you can apply algebraic identities. Now here, whatever is given, so it is okay. OP is how much? 7 centimeter. Clear? PQ. I think PQ is not. PQ square. 1 square. Okay. 2 PQ. Okay. PQ square. Okay. 7 sevens are 49. PQ square. Clear? Clear. What will happen? When it will come this side, so it will come with a minus here. So this plus and this minus will cut. Now what else we have? From this linear equation, we are getting value of PQ. When we will get the value of PQ, then we can easily find value of OQ. How? Look at it. 2 PQ, okay. 49 minus 1, okay, no problem. 48 upon 2. I think 24. PQ is how much? 24. Now it is telling you measure of this side. PQ is a 24. Measure of this side is a 24. Now what about this? So from this, here we will substitute value of PQ, then we will get OQ. So OQ 1 plus 24. So first 25. Of course 25. So it is how much? This is a 25. Clear? This is a 25. Now we have measure of all sides of this given triangle. Now till here we are done. Next sentence, let's read. Determine the value of sin q and cos q. So only sin q and cos q. Okay, sin q, cos q. Now here, look at here. Okay, look at here. Look at the angle. What is angle? Where is angle making? Where will be angle? So here it is this is q. Angle is here. According to this, angle is here. Angle should be here according to this. Now if angle is here, so opposite of this side would be what? Perpendicular. And this is fixed. Okay, we cannot change this. According to theta, this hypotenuse will not change. But according to theta, perpendicular side and base side will be changed. So opposite of this is what? As you know, opposite of theta is perpendicular and this is the base. Clear? So okay. So it is ratio of this is what, P upon H, and P is 7 and H is 25. Okay, this is what we got from this figure. Now one more, which is last for this question, cos Q. As we know, ratio of this is what, B upon H. B upon H. Clear? Now here, according to Q theta, it is where, here, theta is here. According to this is a perpendicular and this is a base. So base is a 24. Base is a 24. Clear? Base is a 24 and H is a 25. H is a 25. Clear? So that's all. That's all. Whatever was the question saying to find, we have found. Okay, this is a process to find this and this, and to find a measure of this side, measure of this side. So this is the process. Logically, we came till here. Clear? So have a look for few seconds, then I will erase to write next question. Next question, I am moving towards the next question. This is the next. Here we will apply what? We will apply value of ratios. Value of ratio. For example, value of what is the value of sine 45? Then you would say 1 upon root 2. So all this we will apply in our question according to requirement, according to need. Here we have this question which is in front of you. It is telling you what will be value of this and this and this and this. Whatever you know a value of this, you will have to substitute, then simplify it, whatever will come. But logically, you should move. You will move. Okay. Logically, you have to move. So sine 60, as you know, root 3 upon 2. Root 3 upon 2. Clear? Yes. I think it would be correct. Now here again root 3 upon 2. So sine 60, I think it should be 1 upon 2. 1 upon 2 again. Here we have put a value of each given trigonometric ratio. So now it will become how much? 3, 4, 1, 4. So we have fraction 3 minus 1. 3 minus 1. 2 upon 4. 1 upon 2. I think something is wrong. Something is wrong. Am I correct? 3 is a 9. 3. Okay. So I think 2 upon root. So let's see what is the answer. So answer is correct. Answer is correct. This is our answer. Yes, that is how you will solve when question is saying put the value of each trigonometric ratios, then simplify it. Then that's how you can solve it, and answer will come this. Answer should come this. Whatever you are applying method, but if question is saying that you will have to apply this method, then you will have to apply that method which question is saying, and then answer is coming this much, then your answer is correct. Okay, now towards the next question. You have this question which is next. Look at here. Read this question. What is it trying to tell you? What is it trying to tell you? Are you able to see question? Here in a triangle which names are what? PQR, okay, and right angle is at Q, as you can see. This is given by question. Okay, you don't need to care about a figure in this question. Okay, in this question, this is a given figure by this question. Here, this statement is telling you right angle is at Q. Clear? PQ, measure of PQ is 3 centimeter, which is given. So here we have written 3 centimeter. PR how much? PR how much? I think this is Q and this is R. So PR is 6 centimeter. Clear? And here determine angle QPR. Here is QPR. QPR. This angle and PRQ. PRQ. This angle. As we know, this is making angle of 90 degrees. So of course this should be what? Sum of this should be 90 degrees. Okay. Okay. We don't know this. If you don't know this, then okay. Still you can find without knowing measure of this. How? So here, according to this, whatever is given here, so according to this theta, this upon this, what will be? So according to this theta, it is a perpendicular and this is the hypotenuse. Hypotenuse is a fixed. Now 3 upon 6. Here can I say P upon H? P upon H is ratio of sine, isn't it? Sine. So where is angle? R. Clear? Now A is a 3 and H is a 6. After simplifying it, we will get 1 upon 2. It is telling you value of this, which trigonometric ratio, which trigonometric value has this much. So you would say sine 30, isn't it? Value of sine 30 is 1 upon 2. Now we will simplify it. So it will cut and we got what? R as 30. It is telling you, this answer is saying you value of this theta is 30. Clear? Value of this theta is 30. Now what about this? It is a simple. According to this theta. Clear? This is base and this is hypotenuse. So B upon H. Otherwise you can say H upon B. You have two options. So I will take what? B upon H. So B upon H is what? Cos theta. So here theta is what? P. Clear? Now here B upon H. B is a 3 upon 6. Again we have 1 upon 2. Here it can be solved further. Cos P is equal to cos I think 60. Value of cos 60 is how much? 1 upon 2. This will cut this. Now we have P as 60. P is a theta. So here it is how much? 60. Now is our answer correct or not? You can check. How? It is making how much? 90. So sum of this and this sum of each interior angles of a triangle is how much? 180. And here 90, 180. That's why our answer is correct. So question was saying you have given measure of two sides of a triangle and you have to identify the value of two angles which is not given. And here you can see we have found what value of this two theta with the help of this measure of two sides which were given. Now it is done. Just have a look for few seconds so that I can write next question. It is completely right. Logically we came till here. Logically we identify value of this theta, value of this theta. Logically. Now something else. Now we will have some question based on trigonometric identities in which we will be applying. Here, one thing more. As you know, according to this, we can write what? H upon P. H upon P. So it is what? H upon P, I think it should be cosec. It should be cosec. Cosec. Clear? Cosec R. Now H is 6 and P is 3, 2. It is how much? 2. H is 6. Okay, no problem. Now it is telling you cosec R. What is the value of which your trigonometric ratio has this much value? So here you would say it is a cosec 30. Cosec 30. Value of this is how much? 2. So here this will cut. So we got 30. Clear? We got 30. So either you can use this method. This is not method. Either you can take this ratio, otherwise you can take this ratio. Now what about this? It can be solved in other way by taking what? H upon B. So as you know, H upon B is what? Sine, not sine, sec theta. Okay, sec theta. Clear? Sec, I think it should be sec, no, P. Okay, P. So H is this and B is this. So 6 upon 3, I think, according to this. So it is H and this is B. So H is 6 and B is 3. 3 to the 6. Again you can see 2 is coming. So it is telling you sec P is equal to sec, I think, sec 30, just opposite of this, sec 30. So P came as 60. Both are same. This, this and this, and this and this, both are same. Okay, you have two options. Now in the next question, there are some questions which is based on this formula, and the name of this formula is trigonometric identity. We will apply this, and as I told you, we apply identities so that we can save our time rather than applying long, then we can find our answer in some steps rather than in more steps. Okay, so that's why we apply trigonometric identity, that's why we apply algebraic identities. Some questions we will take in, and by applying this formula we will see what will happen when we will apply this formula. So what will happen? Answer will come. So logically we will see how does it work. Okay, let's see. Next question. So this is slightly different from this question, and in this question this formula will be applied, this formula. So here this question, if cosec theta is a 3x and cot theta is a 3 upon x, then find the value of this value of this. So as we know, this is a question based on this, then we can apply what, cosec. So here this can be applied, this can be applied. How? Here we have a square, so here from this we know that what will happen, 1 plus, otherwise you can say cosec a square theta minus cot a square theta is equal to 1. From this, okay, from this, now here we will substitute the value of given value we will substitute it. Value of this is how much, 3x, 3x square, clear. Value for cot theta is 3 upon x. We applied this formula according to this, and here we have this, as you know, it will give us this. It is telling you that you can apply this, and this question is based on this. It is, question is saying you will have to apply trigonometric analysis. Now simplify it, 3 3 is a 9 x square, again 3 3 is a 9 x square is equal to 1. Clear? Clear? Here what is happening, 9 is common, here 9 is common. Okay, 9 is common, and we have to bring this much. So how will it happen? X square, 9x4, and this is as it 1. So here 9x4 minus 1, x4 minus 1 upon x square. 1 upon 9. So can we write x square upon 9? So what is happening? Here we can take a common 9 here. Here x square minus 1 upon x square is equal to 1. Clear? What else? We will bring this aside, x square minus 1 upon x square, this 1 upon 9. Okay, So we should have a 3. For 3 we can do one thing, just multiply this 3 in both sides. X square minus 1 upon 9 multiple 3, this 3. Clear? Now what will happen? 3 as it, and here uh, so this is correct. We have this much, x square minus and 1 upon 3, 1 upon 3. So this is our answer. Clear? This is our answer. We have got this much. So value of this is how much? 1 upon 3. Value of this is 1 upon 3. Clear? Now next question. This is the next question. Here, prove that this LHS is equal to RHS. When we will simplify this, however, with logically, then it will be equal to this. Let's see. So LHS, clear? LHS, how much? 1 minus sine square theta sec square theta. As you know, this question is based on this trigonometric identities. That's why we can apply what this identities and this. So 1 minus sine square is equal to cos square theta, because as you know, cos square theta, sine square theta plus cos square theta will give you 1. So from this we can say it is equal to cos square theta. How? So when this, okay, this sine square theta, okay, clear. This will come this side minus 1 and this will go like this. Clear? To remove this, you will have to shift operators of this side opposite. How? So here this 1 and this is a with a minus, this will become plus, and here like this. To remove this, that's all. So easily you can see from this we got this equal to this. So can you say cos square theta, okay, multiple sec square theta, sec square theta. Clear? We will bring this much 1. Look at this. So here what is happening? What is happening? Cos square theta, okay, multiple. It can be written as, to bring 1, we can say that it can be written as 1 upon cosec square. 1 upon cosec square. So this is equal to this much, as you know. It is a basic. It is the basic. Okay. So what I am telling you, what I am saying to bring this much, we can write this as 1 upon cos a square theta. Clear? So now what is happening? It is cutting this one. So we got only one. So that's how we brought 1. Now we can say value of this is how much 1, and it is equal to RHS. Clear? Clear? Can you bring from this much? Yes, it is a possible. How? Let's see. 1. Okay, 1 is what? And here we have sec a square theta. So we can apply this square, this. Okay. So can you say sec a square theta and minus tan a square theta is equal to 1, isn't it? So we have this to bring this much. We can one thing, sec a square theta, it is what? Sin a square theta upon cos a square theta. Clear? No problem. Clear? No problem. Clear? Now what is happening? It will remain same. Sec a square theta minus sin a square theta. I think 1 minus sin a square theta. 1 minus sin a square theta. Clear? Clear? What else? Then we have what? So it is possible to bring this much by this. So by solving like that you can bring. It is in your hand. Next question I would like to write. Let's see next. Now let's solve this. Let me explain this. Here it can be written as 1 upon cosec. It can be written as 1 upon sine. So only one from this bracket you just convert only one, either this or this. Okay, as you know, it can be written as what? 1 upon sec. It can be written as 1 upon cos. So only one thing, one term you convert as here sine. Okay, okay. So let's see sine. It can be written okay this much, clear, and this as it. Okay, no problem. We have fraction. Here we have fraction. Similar here, 1 upon sec theta, 1 upon sec theta minus sec theta upon 1. Same here we have fraction. So this is cosec theta, 1 minus cosec square theta. Clear? Cosec square theta. Clear? Again here sec, 1 is sec theta. Sec theta minus, I think it should be sec square. So it is only 1 because this ones are this and this ones are this. Sec square theta. Clear? Here we have fraction. You know what to do here. So now we have what? We will cross multiply. We will do cross multiply. This with this, this with this. What will happen? What will happen? So sec theta minus sec theta into cosec square theta. Clear? Clear? Cosec theta minus cosec theta into sec square theta. Clear? This is what we are getting. And in denominator, this multiply this cosec theta into sec theta. Clear? Now here in this bracket we have one thing common, which is the sec theta, and in this one thing which is the cosec theta. Clear? So sec theta can be taken as common. Now we have 1 minus cosec square theta. Similar here, cosec theta 1 minus sec square theta. Clear? Upon what will happen? So cosec theta into sec theta. One thing you can do, it will cut this and it will cut this. Whatever you have, whatever you have. So 1 minus cosec square theta. 1 minus cosec square theta. And 1 minus sec square theta. Here we are getting this much. Sin square theta plus cos square theta minus cosec square theta. Clear? Sin square plus cos square theta minus sec square theta. Clear? So sin minus sin minus. Let's apply another method. I can bring this much by doing like that, but it will take time. Now, other method. Sin theta minus 1 upon sin theta. Cos theta minus 1 upon cos theta. So here sin square theta, we have fraction here. This is the same, that's why this will be as it. So it is in bracket. In another bracket, cos theta will be in denominator, and this will become cosec square theta minus this is the same, that's why it will be as it. Clear? Now cross multiply. cos into cos theta into sin square theta minus 1. Okay, sin theta into cos square theta minus 1. Clear? Minus 1. Now what can be done? Cos theta sin square theta 1. So as you know, 1 is cos square theta plus sin square theta. Clear? Similar here, sin theta cos square theta minus it will become minus. Theta plus again it will become minus. Clear? Now here one thing can be observed. Is that from this cos theta can be taken as common cos theta. So we have sin square theta plus cos square theta. Okay. Now minus sin square theta. It will cut. We have cos plus cos.